Example 4.12. Find the present value of an annuity of 500 every year for 5 years if the first payment is made in 2 years. Assume that money is worth 6% compounded annually. So other than the payment that is being made late, which is in the first payment in 2 years, everything else is the same as ordinary annuity certain. Okay, so let's try to look at it on how to solve it. Find the present value of an annuity of 500 every year for 5 years. Okay, 500 every year for 5 years. This is actually the case of annuity, obviously, because it has an equal amount of money being paid at equal interval of time, which is 500 every year for 5 years. But then the difference is that the first payment is being made in 2 years. So let's try to look at it in a timeline. So basically we have 6 years. And the first payment is actually being made at the second years, right? After the second years. If you try to refer here, in the second years. So 500, 500, 500. Sorry, 500 and 500. So basically this is what happened. Alright, okay, so how do we actually find, let's try to look what the question one again. Find the present value. So the total amount of money being paid here is 5,500 for 5 years, so basically 2,500, but that is actually by including the value of annuity, the value of interest. But then we want to know what is actually the present value here after we excluding the interest. So basically we know that this is the case of annuity, but then how about this too? There is no equal payment at an equal interval of time. Okay, an equal payment at an equal interval of time only start at the second year toward the end. So basically, to calculate for the present value, right? Yes, we can use annuity, but only up until this point. Basically, by using annuity formula, we can only find a present value up until this point. Why? Because the annuity cases, which is that have equal amount of payment at an equal interval of time, start from this point until the end, not the first two. So how do we calculate the present value? Okay, so before we proceed, let's do it one by one. Okay, now we know that we can use annuity to calculate the present value for this part. Okay, so let's do that. So let's use the present value formula. Okay, and 500 is actually the equal payment made, right? And the interest rate is actually 6% compounded annually, 0.06, and in 1 year annual is 1. And for how long? For how long does actually the payment being made that involve this 500? So as we can see here, 1, 2, 3, 4, 5. So basically 5 times only. So let's input 5 here. And this is 0.06 over 1. Calculate this and you should get 2106.18. So this present value here, 2106.18, is actually the present value at this point. It is not actually the present value that the question wants. The present value that the question wants is the present value at this point, which is literally a present value. This is, even though we say that this is a present value, but this is still 1 year ahead. not actually a present value. There is still an interest counted at this point, but we cannot use the annuity method directly because there is no annuity involved here. So at this point it is 2106. How do we actually find the annuity? Find the present value at this point? By using the formula, the present value formula for compounding. So because there is no annuity there, what's left? A compounding method. So what is actually the formula for the present value of compounding method? So we have the value of S, which is this 2106.18 times with 1 plus I. I is actually the same as what we informed in the equation, 0.06.1 to the power of negative n. So what is the value of negative n here? So if we look back at the timeline, we want how long does it involve with compound calculation here? Only 1 year. Okay, so basically the n here is 1. Okay, now when you calculate it, you should get 1986.96. This is actually the actual present value for this case.